Okay, so we're going to do some work on finding the mean, mu, and the standard deviation, sigma, if a variable is normally distributed. And this example we actually did in the lesson on Friday, but I thought I'd go through it again just so everyone's got this note, and if anyone wasn't in on Friday or didn't take the notes down, you'll have it in your notes now. So if we're asked to find the mean, mu, or the standard deviation, sigma, or both, then we need to standardise our normal variable first. And don't forget the standardised normal variable is denoted z, and that's a normal variable with mean 0, so centred on 0, and standard deviation 1. Okay, so let's try this question. So if x is normally distributed, mean mu, standard deviation 5 here. Now don't forget that's a really common error that people forget that is 5 squared. I always like to write that out. So our standard deviation is 5 here, and the probability that x is less than 18 is 0.9032. Find the mean, find mu. Okay, so we need to start off by standardising this normal variable. And what we did, if you remember from Friday, z, to standardise any normal variable, we need to subtract the mean and divide by the standard deviation. So this is just a bit of coding to get us this variable z. Okay, so let's look at this. So the probability of z then, rather than x, is less than the x value, which here is 18, take away the mean, which we don't know, mu, divided by the standard deviation, which is 5. And that's equal to 0.9032. Okay, so now we're going to use our inverse normal function on our calculator. So I'm just going to get my calculator. Hopefully that's in screen now. And so from that, what am I going to do? I'm going to put in this normal distribution, and I'm putting in this area to work this out. So I'm just going to draw a little diagram to illustrate that. So I've got my normal distribution. It's a standardised one, so it's centred on 0. And I want to know what this value is of z. That's going to give me an area of 0.9032. So that's going to be somewhere over here, probably a bit higher up actually. But z, what is the z value there? It's our 18 minus mu over 5. And this is the area that is 90.32%, 0.9032. So let's do this on our calculators. So we're going to go to setup, 7 to get our normal. I want my inverse normal function, and the area is the probability of being less than. So it's always this sort of cumulative area down to the left-hand side. So that, in this question, is 0.9032. Okay, and you can see I've already put in there my standard deviation of 1, and my mean was 0, and then here it's given us this value. So what does that mean? It means this value, the z value, is 1.30000289. Okay, and now we need to rearrange this to find the mean, mu. So take the 5 up, sort things out, rearranging. I'll let you do that. You can pause the video, and you should end up with mu equals 11.4999855, etc. So 11.5 to 3SF. Okay, so that's example 1. Example 2 then, now we're going to have a look at finding the standard deviation rather than the mean. So it's just the same sort of question, but just the other way around. So let's have a look at doing a question like that. So, sorry, let me just get that in the screen. So there's our question. If x is normally distributed with a mean mu, standard deviation sigma, and the probability that x is greater than 20 is 0.01, find sigma. So we're going to start off, just as we did before, by standardising this question. So what does that mean? Z is greater than the x value minus the mean divided by the standard deviation. Okay, so here let's just tidy it up a little bit. So z being greater than 9 over sigma is 0.01. What does that look like? So centred on 0, it's just 1%, so it's going to be over here. So my Z, which is 9 over sigma here, that's going to be around about there somewhere, where this is my 1%, my 0.01. Now what we've got to be really careful with here is on the calculators, we mustn't put this in, because our inverse function on our calculator only does our less than or equal to area. So it does this area here. So that's what our calculator can cope with. So that means I'm going to need to change this to a less than probability. And don't forget, because it's continuous, being less than or equal to is exactly the same thing. We're just going one side or other of this point. And that's going to give me 1 minus this. So the 99%, the red part here. So again, now what we're going to do, we're going to look this up on our calculators. So we're going to get our, I'll start it again just so we can see. We're going to get our normal distribution. We're going for inverse normal because we know the probability. We want to go back to the actual value. And in this case, the area is 0.99. Standard deviation 1 because it's a standard normal. Mu is 0. Let's scroll through that. So that tells me that 9 over sigma, that value, is 2.3263, etc. Little bit of rearranging here. Sigma up, 2.333 down, sorry, 326, etc. down. And we should end up then, or you should end up with, pause it, have a go, 3.86872. So 3.87 to 3SF. Okay. I'm going to stop the video there. I'm going to get another question, which is on questions where you have to find both the mean and the standard deviation. To do that, we'll need to set up some simultaneous equations. So I'll do that next. Hope you're all okay. Watch the next video in a minute.